Okay, so let us continue with sorting algorithms. This time we'll consider two even simpler algorithms which run in time n square. Okay, comparison sort and bubble sort. These are by far the easiest algorithms for sorting, but they run in time order n square. Whereas merge sort is faster. Merge sort runs in time order n log n, as we have seen before. Okay, so how do we do this? So once again, we are given an array A1 to n. Okay, and recall the swap algorithm that we saw before. Okay, swap Aij is supposed to swap the ith and the jth elements in the array. Okay, and that's all we do. In comparison and bubble sort, we simply go on swapping the elements. Right. So how do we do comparison sort? So let's give it a name, comparison. Okay, the input parameter input is just the array. We have the algorithm between start and stop. Right. Now what do? We are basically moving across indices, right? Given any AI, we are supposed to compare it with AJ where J is greater than I, right? So for I going from 1 to A dot length minus 1, because AJ is going to be, J is going to be greater than I, right? And J will go up to length. And then we run across J equal to I plus 1 to A dot length, right? This is what we do. Now what do we have to check? We have to compare AI and AJ, okay? Now as we agreed, when we do sorting, we are supposed to arrange this in ascending order, okay? So when do we have to swap elements? When it's greater than or equal, right? So if AI is greater than or equal to AJ, okay? So this is the notation when you want to check greater than or equal to in algorithms, okay? So if AI is greater than or equal to AJ, you want to swap. If it's less than, then you don't have to do anything, right? So if this is greater than or equal to AJ, just swap A, I, J, nothing else. That's all. And that's it, end if. And you're just looping around I and J. So this is it, and for, and for. That's all we do in comparison sort. Okay. So once again, go back to the lecture videos and check how we used to do comparison sorting. It's the simplest form of sorting that we can think of. And this is exactly what we do when you sort. What is this basically? This is basically finding the first minimum, then the second minimum, then the third minimum, and so on. That's sorting. Okay. When you do this, for I equal to 1, you are finding the first minimum. Then for I equal to 2, finding the second minimum, third minimum, fourth minimum, and so on. That's all you're doing here. Okay. So that is comparison sorting. The next version that we want to see is equally simple, slightly different. That's all. What is that? Bubble sorting. Right? Bubble sort. Bubble sort is also more or less the same idea, but instead of comparing this way, we will compare only consecutive elements. Right? So let's call this bubble sort. Yeah. Once again, this is what we have. And now how do the elements move? Once again the same way. So the first loop is going to be the same. I equal to 1 to A dot length minus 1. Now the second one is interesting. Second one is supposed to go for J equal to I plus 1 to A dot length. Right. But what are you comparing? You're not comparing AI and AJ. You're comparing AJ minus 1 and AJ. Understand? The consecutive elements. So when I is equal to 1, you compare first A1, A2, then A2, A3, then A3, A4, A5, A6, and so on. That's what you're doing. Right? So if this is true, then what do? Again, swap these elements. That's all. So swap A, J minus 1, J. That's it. What else? Nothing else. Keep doing this. At the end, your array will be sorted. Right? End for, end for. That's it. So Comparison and bubble sort more or less have the same structure because we are just looking at all possible pairs essentially, comparing them, and whenever it's greater than or equal to, we are swapping them. Two ways to do this. One is, go series wise. First fix I, then arrange across all j, then next value of I, then range across all j, and so on. Otherwise, start with the value of I and then just go on comparing consecutive elements. Then start with I equal to 2, then again consecutive elements, then again consecutive elements. Right? Finally, at the end, you will get the sorted element. So bubble sort also we have seen in lecture videos, again via diagrams and examples. This will be the precise algorithm for it. Okay, so yeah, in this short video, these are the only two things that we do. So we will stop here now.